Okay, good morning, Rando Postiglione. This is for Joliet Montessori math. Today we're going to be talking about, this is actually a revisiting uh, to working with binomial factoring, binomial multiplication and trinomial factoring. Okay. In essence, it's all about solving equations. Okay. Um, let's see. When we talk about solving a quadratic equation is just when you have an x that's squared. Okay. X cubed, x to the fourth. Those are called different equations, and we can talk about that at in a later video. So anyway, before we get into it, all right, I'm going to show you the agenda in a minute. I want to talk a little bit about the content checks. Okay, I haven't seen all of them from you. I'd like to see them before the end of the week. Today is Thursday. Today is April 16th, and I have been returning them, going over some things that you got wrong, but I haven't seen everybody's, and I really want you to take these seriously. I'll be emailing moms and dads if you're not scanning and sending this work back to me. These are hard times right now. I understand it's critical that you do other things, but hey, we got to get through this year, and these last few weeks were, gosh, I was planning a whole heck of a lot, to get you guys ready for next year. Uh, okay, this you can stop the video. This is the agenda for today. It is the 16th, and we're talking about all this stuff. Okay? All right, hope you got that. The title is Revisiting Multiplying and Factoring Binomials and Trinomials. You multiply binomials, okay, and to get trinomials, you factor trinomials to get binomials. Let's see. And by knowing how to do these things, you can solve equations. What can I say? Okay, it's not rocket science, not yet. Okay, so the first objective is students will be able to identify equations of the form ax squared plus bx plus c equals 0, which looks something like this: ax squared plus bx plus c equals 0. Now, I go to a lot of different textbooks. Some call this the general form of a quadratic equation. Some might even call it standard form. But there are several different forms of quadratic equations where x is squared. Doesn't matter what you call them, not really. It's just what's important is knowing how to use them. And where this is all leading is graphing. How we take this equation and show what it looks like, okay, in the coordinate plane. All right, that's when we can predict. That's when we can illustrate just what's going on in a relationship between X and Y. All right. Now, you don't see any Y here, okay, because the 0 would be the Y. All right. Remember, when you find out what X is, all right, you're actually finding the x-intercept, okay, when y is 0. And if you know where the x-intercept is, that's going to help you a lot in graphing the equation. Now, what's cool about quadratics, x has 2 values most of the time. You know what? Maybe all of the time. Sometimes they're the same number, okay. But and you'll see. By the way, I'm giving you CUDA worksheets along with this. All right. So anyway, let's look at an example. Here's x squared plus x equals 0. Okay. Now, oh, you know what? It's not 0. It's 20. 20. Okay. Now, we want to solve for x. And if you notice, if I subtract 20 from both sides, I'm going to have an equation of this form. Okay, I hope you can see that. Use a different pen here. All right, so I'm going to subtract 20 from both sides. X squared plus x. Now I'm subtracting 20. All right. So over here I'm going to have my 0, but over here negative 20, right? Okay. All right, now you have to ask yourself, could this be factorable? Let's try. We know it's we know that it's a quadratic. We know that it's a trinomial. All right. And I know that the square root of x squared is x. So I'm going to put an x here and an x here. Okay, x times x is x squared. Now, I next turn my sights to the 20. Well, I know I've got different factors of 20. 2 times 10, 4 times 5, 20 times 1. I like 4 and 5. So I'm going to go with 4 and 5. Now, I'll tell you why. Once again, and I've said this to you before, when you look at this constant term, you're looking for numbers that when multiplied gives you this number, but when added gives you the coefficient of the middle term. Okay? 4 and 5 does it for me. 2 and 10 doesn't. I'm never going to get a 1 adding different values of 2 and 10. But 4 and 5, if I make this a plus and this a minus, I think I've done it. I think I've factored this. I go back, x squared, then plus 5x, negative 4x, negative 20. That's just distributive property, right? I've got 2 mailmen here. Okay? Now, we've done this before. That's why I said, we're revisiting this. I know that this is a factor and this is a factor. This factor times this factor is supposed to give me 0. Okay? Now, one of those or both of them has to equal 0 to give me a 0. I'm going to assume that both of them equal 0. So x minus 4 equals 0, x plus 5 equals 0. And if you notice, x equals plus 4, x equals negative 5, okay? So we could say, notice these are our braces, 4 can equal, x can equal 4 or negative 5. So much so that if I take the 4 and plug it in here, I'm going to get this side over here, 20. Let's see. 4 squared is 16, plus 4 is 20. Negative 5, this is going to give me 25 minus 5, 20. Okay, I'm good. So, what this tells me is that if I were to graph this, and we'll get into this later, you may not understand it right now, but if I were to graph this at 4, 0 and negative 5, 0, I get a curve, okay, that's crossing the x-axis at those points. Okay? All right. Now, that's the first part. I think I'm going to stop this. Right, I'm going to stop this, and when we come back, we're going to do something a little different. Okay? See you then.